Hey guys, it's Vince. Today in this video we're going to be discussing relays, and the main reason I want to talk about relays is because there's a lot of different information online, but I'm noticing more and more as I do research that a lot of the information is convoluted, it's got a lot of holes in it, and I want to make you guys empowered in understanding how powerful relays are when it comes to your CNC system. Many of you already know that they make your life a lot easier as far as letting you control different variables with the software, but the main thing that I want you guys to understand is there's two different types of control configurations for relays that many of you may or may not know. The first term when dealing with a relay is the most general one. It's called a wet contact relay. Now, a wet contact relay is simply termed wet due to the fact that it's receiving voltage and current. A dry contact relay is the second version of a relay, which again, that type of relay simply means dry. If wet means you're getting voltage and current, dry means you're not receiving voltage and current. So it's basically just completing a circuit in a loop format. Okay, let's look at the two hookups here. Really arbitrary. Okay, I cannot emphasize enough when I say arbitrary, I'm letting you guys know that this is random in the sense that right now I'm displaying a relay that's rated at 48 volts, 30 amps. It's an SPST relay. I'm not going to get into the whole forensics of what type of relay it is. Just keep in mind it's arbitrary. Whether you're using a 24-volt relay, a 12-volt relay, 5-volt relay, it's all going to be virtually the same hookup configuration. The main difference is going to be in your configuration as far as connecting it, okay, utilizing the relay to activate whatever you're trying to activate electronically. So let's look at our first relay, which is the most general, the wet contact relay. Okay, right now, being we're using a 48-volt relay, you will be using a 48-volt lead that goes to the power supply. It's the positive terminal to the power supply. That will end up powering the relay to become active. Now, the output on the relay, you can see here, it goes to your breakout board output terminal. Okay, whatever outputs you have on your breakout board, whether it be a G540, which would be terminals 5 and 6 on its terminal block, or if you're using a breakout board for individual drives, you would simply run that lead to the output, and that output is just waiting for that board to send a signal from Mach 3 or whatever motion control software you're implementing and triggering the relay. Okay, so once again, you got your voltage, that's your hot lead going in, and that's at the rating of the relay. So if this, for instance, if this relay was rated at 12 volts and not 48, this would be going to a 12-volt power supply, okay, in order to power the relay. Now, the next thing on a wet contact relay, once again making it wet, on your COM input, you would run an AC voltage typically of 120 volt to 220. Now that's not always to say you're always going to be running AC. You can run DC as well. Typically it's AC. So keep that in mind. Relays in general, you'll be running voltage to it. Okay, so in most cases, like I said, with CNC, your AC voltage will be 120 volt to 220 in a wet contact relay configuration. That would be your live wire. That's why I've got the L here, or your COM on your relay. And again, that's your voltage going into the relay. Now, your normally open contact on the relay, okay, will become active once again once that output from the breakout board sends the signal. It then triggers your normally open contact, which then gets run, and this is a GX16 3-pin connector. And the main reason we use a GX16, first of all, it's industrial rated. It'll definitely handle the voltage, and again, very, very safe connector. Either way, your normally open contact would come over to pin 1. Your neutral contact would be coming over, and again, from your power supply to pin 2. Your ground contact would come over to pin 3. Once that output signal is then triggered from your breakout board, turning on the relay through Mach 3, or once again, whatever motion control software you're using, you would have your AC voltage coming to this connector. Okay, so whether it's 120, 220, whatever it may be, it'll be coming to this connector. Now, coming over here to a dry contact relay, the thing to keep in mind is the one thing that's missing is the voltage. Everything else is exactly the same. Your output going to your breakout board outputs, once again, your voltage, 48 volt, once again going to your actual power supply if it's rated at 48 volts. Once again, if it's rated at 12 volts, 5 volts, whatever it may be, that will go to the positive terminal on that power supply, signifying the voltage rating of your relay, and that will once again trigger the unit. Coming over here, your normally open contact would now go to typically pin 1, I'm just saying this arbitrarily. You can put it on pin 2. This is my own preference. Once again, you'll have your own. I just find this to be the most simple. Normally open going to pin 1. Your COM connection would go to pin 2. You see there's no voltage coming in here, where down here on a wet contact, you actually have voltage coming into the COM port on the relay. On this relay, you have absolutely no voltage. You're simply just running it over to pin 2 on the GX16. Pin 1 would be normally open, and pin 3 would be your ground. Okay. Some guys don't even use ground. I personally do. That's my personal opinion. But again, everybody is different. I recommend if you can use a ground, always use a ground. And to show you a contact, and this is for my plasma guys, because you guys, I sometimes feel I leave you guys out, kind of. I don't mean to. But I'd like to do more videos explaining about plasma system components, because I know the hookups on them can be sometimes confusing. If you look at this actual diagram, and this is what we typically find online, you could see that this torch's trigger is actually using a dry contact. There is no voltage coming in here at all. You got a COM connection going over here, and you've got over here your normally open connection coming over here, and it's just going right to the torch. So once again, looking at this, if you guys encounter this, now everybody's plasma system is different. You guys are dealing with a totally different animal than my guys dealing with routers and mills. So I want you guys to understand, a lot of times I get questions where you guys will say, hey, I want to build a plasma system. I need to know, what kind of controller I need. Give me a quote, blah, 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 blah. What you have to understand is there's so many variables with a plasma system. First of all, I always try to recommend the torch height control that you guys are going to want to go with that is matched to your torch to give you the best optimal use, so to speak, between the both of them. When you guys are building a plasma system, you're dealing with many more variables than the other systems. You're dealing with your torch height control. You're dealing with any switches implemented on the torch height control if it's a floating head. You're dealing with extremely high amperages, which most systems don't deal with, which means you're more susceptible to EMI penetration, which, again, anyone who's run a plasma system will tell you EMI is the biggest enemy you could possibly have. Grounding the system takes hours to do properly. I've got the hypotherm engineering diagrams for that on a couple of my videos. Many of you have requested them. It's worth the time to take to do it right. But going through all those variables, even with the relay hookups, you can see here's one relay, and really we don't even see this actually being really completely connected. It's just present right now. He does have the actual connections, once again, running to a G540 and then the 48-volt side running to the power supply. But this relay is actually triggering his torch. And once again, with the dry contact configuration, you can see here exactly how it goes. Now, once again, and I want to just clarify because I get questions on this as well. When you see an actual diagram where it's going directly to the torch, guys, I do not recommend you just wire it directly to your torch. Make it so that your relay wires to a connector, like I said, the GX16 here. Let's just scroll down a second. A GX16 connector here in your enclosure, and then run an actual cable that would be double shielded, preferably if you're using a plasma system, to your torch. This way, it's pluggable. You're not dealing with something that's hard mounted or drilling holes through. I've seen some really cockamamie contraptions. You really want to try to keep everything as clean as possible. Once again, for your own sanity and also to make your system function as it should. You want to have that cleanness. So if you go to work on it, you can unplug the actual cable from the torch itself, going to the relay, and not have to affect where your controller is. And as wiring gets more and more in depth, especially as you're doing it yourself, this configuration here with the touch and go micro switch, which is basically used for a floating head, you can see here this looks pretty basic. But all of a sudden, once you start putting all this stuff in your enclosure or getting ready to, I see a lot of guys doing bench testing, which is fine. I totally recommend doing that. But try to keep everything isolated. The more you make it convoluted, and, again, wiring diagrams look so neat when you're looking at them, but when you have everything on the bench, it becomes a mess really quickly. Try to isolate everything as much as you can, and use that same format inside your box, and it'll make things go so much faster. You'll be so amazed on just how nice and neat everything can be. So once again, just so we're all on the same page, you got a dry contact relay configuration here, once again, for my plasma guys. So as you guys go through now, not every plasma will always use a dry contact configuration. However, most will. So it's something to think about as you get more and more in depth and look at exactly, your torch. If it's a Hypotherm, all the other brands out there, you want to validate with them what kind of relay they require. Now, most of our engineers will tell you, you need a dry contact. And I've had guys message me, what's a dry contact? And they Google it and they figure it out. Honestly, most of you will be using that. Now, even with mills, if you're controlling your spindle, you can find that a dry contact hookup is also recommended in certain instances. If my guys out there who are trying to turn on a spindle and just control the actual voltage going to it, you would use a wet contact. If you're doing it where you want to control different features, you may be entailed to run a dry contact. So once again, just pay attention. And the easiest way to pay attention, if they're not being specific as far as what relay to run, like this image, you see nothing here where whoever actually created this image actually put in here 48 volt relay dry contact. They should have. Okay, they may not even understood what that means, but right here, that would be the defining factor if you're looking at it and not an engineer or not someone that understands and works with this on a daily basis. I don't run power to this, I'm simply just doing a loop. And that's exactly what signifies a dry contact relay. No power, no amperage, your dry contact. Voltage present, wet contact with amperage. So keep that in mind, and hopefully this will help you guys, this short video. But now you guys understand what you're dealing with, and when it comes to actually setting up a relay for your system, if you notice either kind of hookup, if you notice that you're doing a normally open and a COM connection and there's no voltage going in, now you know exactly what you're looking at, and you guys can go from there. So once again, I want to thank all of you. I've been very, very busy. I'm trying to get more videos up, but I want to tell all my subscribers I do love you guys. I will keep the tutorials going. And again, I hope one of you have at least gotten help out of this. I think it's beneficial. We all stay on the same page. And like I said, trying to keep everything less convoluted from online, because I know there's a ton of diagrams hitting the market. And the diagrams are extremely helpful, but if they're not defining certain features of what components you're hooking up, it can be even more confusing. So again, I hope this video has been helpful. If you guys have any questions, once again, my general email is storm2313@gmail.com. You can also contact me directly through my eBay store at eDealers Direct. I'll put that in the description below. Once again, I love you guys. Thank you again. Have a great weekend. Take care.